Okay, so now we're going to finish this off. Now, hopefully, you've had a go at it already. Right. So the first is the easy one, just kind of figuring it out. So we've got our variables. So we had T12, dBl T12 as double. Now here you can already see that an array is actually easier because it's just easier. You can do all of these kind of in one go. But anyway, and if you've done an array, fair play. We've got 2, 2. And finally we have 1, 2, which I already have double. Okay. We also have a row counter here. Okay, the initial values. So I've got different initial values figured out. dBl T12 equal to minus 75. And dBl T21 equals 225. dBl T21 equals 225. I've already done that one. 22 is equal to minus 75. And dBl T11 is equal to 225. And the row is equal to 2. And now we'll do our loop. So we're going to print the currents now. We'll just have a look at where we're printing these. Cells int row column 1 is equal to dBl T12. And we'll keep just kind of, you have to be very careful of copying and pasting. Often the mistake people make here is they'll copy and paste and just make a silly mistake. So we're going 1, 2, 2, 2, 1, 1, and 2, 1. So that's printing the current. That's done. And now we need to calculate the next. So we're basically just going to write down the formulas. We're going to use Gauss-Seidel here. So we just write down the formulas I wrote. So dBl T12 is equal to minus 90 plus dBl T22 plus dBl. So yeah, so actually, as I'm writing this, the arrays is actually far easier. And now I'm going to copy and paste here and hopefully not make a mistake. So the next one is 2, 2. And that's beside a minus 90 and a minus 60, but 1, 2, and 2, 1. 2, 1. The next one is 2, 1. So these are the temperatures, or the equations, formulas that I developed earlier on. So 1, 2 is beside actually minus 30 and 480. And it's beside 2, 2 and 1, 1, same as this one. Okay. And what about T12? Well, last one is 1, 1. And it's beside 480 and minus 30. And look, there's that little stupid mistake waiting to happen. And this is beside 1, 2 and 2, 1. 1, 2, 2, 1. So just have a check. 1, 2 is beside 2, 2 and 1, 1. 2, 2 is beside these. 2, 1 is beside these. 1, 1 is beside these. And the temperatures look good. Okay. We also need to put the row up. And then the stopping rule. So the stopping rule is the hardest bit, but what you're going to do is you're going to do AND statements. Now be very careful with copying and pasting here, because a stopping rule that's broken will mean an overflow. And now can I remember how I got on to the next line? Do I do an underscore? Yeah, I think that works. I'll do another one there, just so I can see everything that I'm doing. So that's how I can go to the next line. Right. So that's 1, 2. So I also want 2, 2. Now where is 2, 2? It's in column 2. So you definitely want to save this before you run it. Next one is 1, 1. 1, 1 is in column 3. And then the last one is 2, 1. 2, 1, which is in column 4. So I'm definitely going to save this. I'll just pause it to say we're back. Hopefully everything's okay. Okay, variable not defined. This is why you use option explicit. Now look, we're getting an overflow error. Okay, now where is it? We're going to find out. Now I need to get out of this. So I'm not so great, I have to, it crashes on me as well, but there is some buttons that you can press. Can't remember what they are. It's not what I wanted to do. I'm just gonna have to end it. Okay, now that's why you save. Lab 7 end. Okay, so something went wrong. How do we figure out how it went wrong? I mean, I could obviously pause the video and go off and find out, but what I really want to do is kind of show you if something goes wrong like this. I didn't do any mistake on purpose, by the way. It just happened like that. So how you find out is you run some F8s. Save before you run. So press F8. So this will kind of do it step by step, and you can see what might be going wrong. Now, we're getting convergence here to 150 and 0. Now, could that possibly be solutions? Maybe just check your equation. It might be just a bit of a coincidence that it does work. So we're looking at T12 is 0, T22 is 0, and the other one's both 150. So just check, is that a solution of the equations? Or is there something weirder going on? So 150, so I'm looking at T11, the adjacent temperatures are 0 plus 150 plus 480 minus 30 and divided by 4, 150, yeah. And by symmetry, that's the correct for T21. Now what about, now we might just be unlucky with the solutions here, because I think the stopping rule can get into a bit of bother if the solution is 0. We look at T12, so the adjacent temperatures are minus 90, said to be 0, plus 150, minus 60, divided by 4, yes. So the solutions are right. So the question is, maybe, is there an issue with our stopping rule? So looking at this, so this is really, really small. This is really, really small. But are we getting what we need to get here? Small, small, 150, 150, but you see it has to satisfy all of them. And I think what's happening is we're getting, the problem is this is becoming very, very small. And so, yeah, so I think it's just very unfortunate. Again, I'm going to have to change things around. I'm just going to pause this to just fix the values. Why is it that there's a problem with 0? I'm not sure exactly, but I do know this stopping rule has an issue then. So apologies about this. I'm just going to randomly change the temperatures on top to 40 and 80. Unfortunately, we're just getting errors with the temperature being 0. I haven't had problems with this before, but I changed the boundary temperatures because what was happening was I wanted the temperatures to be continuous at the corners so that they'd match up, but unfortunately it's going to wreck things. So I'm just going to change, it's just going to cause a change to this to be, instead of minus 90, this will be 40. And for T22, this will be 80. So hopefully now we get it working. So we'll save it before we run it. Off we go. Yeah, it worked. So delete these. Here we go. So if we want, we can kind of, write them down in our thing. But maybe I'll just do, I'll take some of them over here. So let's use 40 pixels, say 41 there. I'm just presenting my answer. So we had temperatures in the top 40, 80, then minus 60, minus 30, 480. This actually be 0 to 480, this would be 0, this would be minus 30, this is minus 60. Now we have the issue with the corners. So the way it's going, it should be minus 90s. But yeah. I want to center all these to make it look nice. There we go. And then the temperatures. So T12 is up here, 52. Can I do this? Yeah. This one is T22, which is this. This one is T11, which is this. And this one is this. And then you can do something nice. You can do conditional formatting if I can find it. There you go. So, well, I think we'd like the colors to go the other way, wouldn't we? So the hot spots are red, the cold spots are green, and we get this kind of behavior. So that's a nice way to present your answer. Apologies about the messing around. Now into the bigger dog, as it were. Now I'm going to follow what it's doing, and the additional properties I'm not going to do so much. If you're interested in this stuff, you can go after these, and I'll show you what you can end up with. So there's actually a bit more that I didn't copy here. Now you might want to follow this exactly. It's kind of up to you. So I'm going to keep on doing what I was doing. So I had in my head that we're going to do the temperatures across here, the temperatures here. So we're going to be printing into pretty much this region here. Okay, but we have a lot of it set up. Okay, so we've done the top temperatures. Now we're looking now at this thing here, this picture. So I want to do the left temperatures maybe now. So let's do left, let's do right, and let's do bottom. And it's similar, so I'm just going to copy and paste, but very careful copying and pasting. Okay, so the left is constant j equal to 1, but the I changes from 1 to 6, and it's equal to 0 down there. On the right, you have a constant j equal to 6, but the row number changes. And along the, now this should be next into I, on the right, the temperature is 20. And then along the bottom, the j is changing, and the I component is 6. And on the bottom, it's equal to 100. Okay. Now here is the initial temperatures, all 0. Okay, so let's see how this goes. So print in a big loop. So for int I equal to 1, 2, 6. For int j equal to 1, 2, 6. Cells int I, int j equal to dblt, int I, int j. Now you can understand if you use a different labeling, it can get a bit complicated. And if you follow what's in the PDF, it's a little bit complicated. So I think I'll be recommending to maybe for once actually watch the video first. The previous video. Okay, now the next values. So we're going to go with Jacobi, because I want to show you something. Before calculating, we need the old values. So we're going to do something similar. Oh, I need to do next int j, next int I. So I need to do something like this to record the old temperatures. So we're going to go from 1 to 6. dblt old is equal to recorded as the previous value. You probably could use the previous printed values, but I think what happens is if you haven't the initial values there, the very first loop gets into a problem because there's nothing. No, you could use the printed values. So this is just an alternative. So or use that dbl. Actually, yeah, or else db is equal to it'll be printed. So you could get the previous one from there. Okay. So, okay, now the formulas. So the formulas are actually not that bad. So similar story, big loop or big for loop, but it's only from 2 to 5 because they're the interior temperatures that are changing. So dBLT is equal to the average of the 4 around it. So dBLT int I minus 1 int j. So that's the temperature to the left. Oh, we're going to use the old values because we're doing Jacobi method. Plus, say, the right, plus top, plus bottom. So to the right, it's I plus 1. The bottom is int I, or int j minus 1. And the top is int j plus 1. Okay, and now the stopping rule. So we'll do the simple stopping rule first. Loop until int c is equal to 100. Now, well, maybe over 100. Okay. Int c equal to 100 is fine, but if you use stopping rules with dBL, you don't want to be using equals. So let's see what happens. Variable not defined. Dim dim is right as integer. Dim int j as integer. Didn't know you need to define things in loop as variable. There you go. Did we save it? Run it. Debug. Subscript out of range. That's because the old isn't set up the whole way. No harm seen me struggle. Don't like that. Earning my money today. So again, really what you're seeing is that it's crucial to save before you run. So again, if you get an error like that, F8. So I'm just holding down F8 and it's going through. So there's the first run. Now it's going subscript out of range. What's your problem? Oh yeah, and what? 1, 2, 6, 1, 2, 6. Save. We'll try again. I'm not seeing anything changing, are you? Oh, I'm a donkey, aren't I? So dBLT old must be dBLT. Save it before you run it. We give it a go. Hey, now that's not, oh crap, spoke too soon. So same crack again. I'm doing Control Shift Enter for this, or Escape for this. Now, I appreciate it's kind of wasting your time here, but the point really is shown. Some people kind of get frustrated, like how should you deal with errors? It's by using F8 basically. Now, why are we getting overflows? So maybe we'll just have to inspect the code, but I can't really see what the problem is. It's like it's not stopping, but I mean the stopping rule is just int counter. Did we forget to put the counter up? Ah, stupid as that. Now hopefully it runs properly this time, or I will start to feel a bit stupid. There we go, thank God. Now again, you can do your conditional formatting to make it look a bit cooler. Excuse the pun. Right. Now we'll do something even cooler again. Now there's lots of things you can do here, right? Really, there's lots of things. So you can include a tolerance. Okay. Oh yeah. So we haven't actually done the stopping rule correctly yet. We should do that. Okay. So the stopping rule. The way we do that is we need that the stopping rule is satisfied for all 16 things, all 16 temperatures. So what we can do is define a stopping rule variable, and it counts up how many of the internal temperatures satisfy the stopping rule. So the stopping rule will go like, so we'll need the stopping rule to hit 16, or maybe bigger than or equal to be safe. Okay, so it'll go something like this: for int I equal to. So we're going to go through the internal grid points. So first of all, we're going to define this stopping thing to be equal to 0, and then if you go through each of them, if now actually the stopping rule should be equal to 0 up here before you go in. If a certain temperature satisfies the stopping rule, so that would be absolute value of dBlt int I int j minus dBlt old int I int j is less than or equal to 0.0005 times dBl absolute value of, I'll just have to be careful, what is the actual stopping rule? Is it new or old? The new value. It's dBlt int I int j, then you up the stopping rule by 1. So every time it goes through all the internal temperatures, and if it satisfies the stopping rule, it puts the stopping rule counter up by 1. Now, if all of them satisfy it, it'll get up to 16. Okay. And it'll stop now. So hopefully now this works. Yeah, it works good. Okay, and it probably didn't need all 16. Now, we said that if we use the Jacobi method, the intermediate calculations actually do have meaning. So what we want to do now is we actually want to pause the temperature in every single loop so that you can actually see the temperatures. Because here you can't really see the temperatures changing. It's pretty much instant. You know what I mean? So for that, I'm going to Google how to implement time pause in VBA. Here we go. The internet, it's amazing, isn't it? So this is going to stop for 1 second. Now you can get issues with it can take, if it takes too many iterations, you get into trouble here and you'll get some messing around. But look, isn't that class? I think that's so class. So those temperatures actually do represent something. If you use the Jacobi method, this is how the temperature of the plate would increase in time. Now we will be looking at this after Easter, I guess. Now you can see it might take a bit too long, so you can adjust the time maybe. It'll eventually kind of get sick of doing this. So maybe we'll go down to 0.5 a second. Will it work? It mightn't. I think that'd be, no, that mightn't be the right one, but we'll give it a go. And we're nearly finished now. And yeah, so you could Google milliseconds in VBA. Look, I don't know. I'll leave it as 1 second. We've probably done enough there. So there's all manner of different things you can do. I will show you what you can do if you push it a bit. So this is one I would have done a few years ago. So I think this one takes in a variable number of grid points. So that's about like making it more accurate. So say I go with 12. How many significant figures? 1 or 2. Okay, so we'll go with 2. Temperature along the top. Well, what did we have there was 0. Temperature along the bottom, we had 100. Temperature along the left, 0. Temperature along the right, 20. And off it goes. There was no time delay in that one, but I think this actually could be yeah, I don't know if that actually should come later. Okay, I've gone on long enough here, so you can do all this, but I wouldn't. I'm not too interested in that.